Curriculum Assessment 1 Review. It's due before you take your CA1 test. Before we start this, let's go over our expectations for this video. Pause the video frequently to try problems on your own. Ask the teacher questions for clarification. Use your TI Inspire in class and the Desmos app outside of class. Complete the review and turn in before you take the test. So let's begin with number 1. Give the domain and range and determine if the graph is a function. So our domain is left, right, x. Our left x would be 0. And our right x is 28. So we have 0 is less than equal to x less than or equal to 28. And if you're to say that the domain verbally, you would put 0 is less than or equal to x less than or equal to 28. You could also say x is in between 0 and 28. Okay, for a range, we have down, up, y. Our lowest y is 0. And our highest y is 9. We're talking about y, so we put y in the middle. You could also put f of x right here. Less than or equal to, less than or equal to. And if you were to write this down in words, it would look like this. 0 is less than or equal to y less than or equal to 9. You could also put y is in between 0 and 9 miles. Okay, so this graph right here is contiguous because it has at least one curve or line. This graph right here is a function because it passes the vertical line test. The x does not repeat. Look at number 2. Give the domain and the range and determine if the graph is a function. So first, what we want to do with the domain, I'll go ahead and put that in blue. We want to draw vertical lines on the left side of our graph and on the right side of our graph. Left, right, x. Let's see what passes through those vertical lines. We have this point, which would be -4, -3. And we have this point, 1, 2. So with this, we want to find the left x and the right x. Our left x is -4. Our right x is 1. We're talking about the letter x, and we put our less than symbols. If you look on the left, notice that is a closed point. We're going to put a line under here. Notice this right here on the right side is an open hole, so there's no line. So if we type this into words, write this into words, you have negative 4 is less than or equal to x less than 1. Okay, so for the range, down up y, we will draw 2 more lines. And you can use a highlighter for this or your pencil. We're going to draw a horizontal line on the lowest part of the graph, the lowest y, and then one on the highest one. Now we're going to label our points. So there's a part of the graph that intersects right here. We will label that. We have -2, -7. And the other point, we already found it was 1, 2. But now we're looking at the y values. So remember, range is down, up, y. The down y is -7. The up y, the highest y, is 2. We're talking about the letter y. You can also put f of x here. And we put our less than symbols. The lowest point, it has a point right here. We could create a point on this line. So it's a line. At the top, we have an open hole. So there's no line. And then let's write in our verbal description. We have -7 is less than or equal to y less than or so less than 2. This is a contiguous graph because it has at least one curve or one line. This is a function because it passes the vertical line test. None of the x's repeat. On this next one, number 3, we would first label all of these points, all 5 of them. Go ahead, pause the video, label each of these points. When you're ready, unpause the video and check to see if you applied them correctly. Okay, these should be the labeled points. Domain, left, right, x. We're going to list these x values in order from least to greatest. So we have our brace, and then you list the numbers. -3, -2, 1, 2, and 5. If you were to write this verbally, it would look like this. The set of x includes -3, -2, 1, 2, and 5. Okay, let's look for the range, down, up, y. We're going to list all our y values in order from least to greatest. So we have -5. So this is discrete because it only has points. If you do the vertical line test, that's where we're going to draw a vertical line on each point. Notice that none of the lines have more than one point at the same time. So that means it passes the vertical line test. That means that it is a function. Number 4, give the domain and range and determine if the graph is a function. We have domain, left, right, x. Let's go ahead and draw our lines. There's the left, there's the right. Now notice both of these are arrows. You circle the arrow. Basically, it's going to the left forever, negative infinity, and it's going down forever, negative infinity. On the right side, we also have an arrow. It's going to the right forever, so that's positive infinity, and it's going down forever. That's negative infinity. So domain left, right, x, we have negative infinity less than x less than infinity. You could also see it as parentheses, negative infinity, comma, positive infinity, close parentheses. You could also see an R with 2 lines. But the thing that comes up the most for this will be all real numbers. So the domain verbally will be all real numbers. For the range, down up y, we're going to first draw a line on the lowest part of the graph where the arrows are, and then the highest part of the graph where the top of the hill is, the maximum. So we could create a point at the top. That point is 2,9. And we're talking about the range, so we're only looking for the y value here. So we'll use this one and the lowest y. It could be either of these, they're the same. So the range, we have negative infinity less than y less than or equal to 9. Now you're not going to see this part right here. What you're going to see is y is less than or equal to 9. So your range verbally is y is less than or equal to 9. This is contiguous because it has at least one curve or line. It is a function because it passes the vertical line test. No x's repeat. Which graph shows a function with a domain of all real numbers greater than 7? So we have domain, left, right, x. Write your x. So of all real numbers greater than 7. And if you forget your greater than and less than symbols, draw a number line. On the left side, -1 is smaller than on the right side. This is less. If you look on the right side, that's the bigger numbers. That's greater. So we're looking for x's greater than 7. Let's look at A. So we have 7 right here. X is greater than 7. Okay? Let's look at B. X equals 7. C. X is greater than 0. And then the last one, X equals 7. The only one that matches this is A. We look at this point right here. We have 7, 3. We're talking about domains, so we're only looking at the 7. On B, we had the point 7, 0. But it doesn't go any further than that. 7 is the only thing X can ever be on this. So it can't be B. On C, this coordinate point is 0, 7. That's the Y value. If it was asking for range, this would have a 7 for the range. But X is 0, so that doesn't work. And D, X is always going to be 7, just like on B. Number 5. Determine if the following relations represent y as a function of x and explain why. Then give the domain and the range. Let's look at A. We have some symbols here. We have our inputs x and our outputs y. Is y a function of x? Yes. Why? Because none of the x's repeat. Domain, left, right, x. We just list all the x values. -2, -1, 0, and 2. Okay, the range, down, up, y, we list all the y values. -4, -3.75, and -3. Let's look at the table on part B. We have our inputs and our outputs. Our input, remember, that's x. Our outputs, that's our y, that's f of x. Let's figure out if it is an f of x though. Is y a function of x? Yes. Why? It's the same reason as this one, x doesn't repeat. Okay, domain, left, right, x. You're going to list all the inputs, all our x values. -1, 0, 1, 2, and 3. Our range, down, up, y, we're going to list our y values. 3, 4, 5, and 7. You only have to name each of them once. 0, 1, and 4. So we have the set of y includes -5, 0, 1, and 4. C, we have a set of ordered pairs. We have 2, -2, 3, -2, 4, -2, and 5, -2. Is y a function of x? Yes. Why? Because the x doesn't repeat. Even though the y repeats, that still could be a function. So X doesn't repeat. Okay, domain, left, right, X. List all the X values. We have 2, 3, 4, and 5. Range, down, up, Y. We list our Y values. We only have -2. And again, we only have to list each element in the set once. Okay, describe the difference between domain and range. Well, for one, domain is the X values, and the range is the Y or F of X values. Okay, let's go to the next page. Number 6. Write out the steps for graphing a scatter plot and finding the line of best fit regression on the calculator. So if you recall from your easy breezy calculator crash course and the notes, we have our steps for finding regressions in the calculator. So first, you click the green beaker to go Vernier Data Quest. Step 2, copy the X and the Y data into the table. Click this table right here. Write all the X's in the X column and all the Y's in the Y column. Step 3, click the graph symbol to graph the points. Step 4, press Menu, 4, Analyze, 6, Curve Fit, and then press 1, Linear. Press Enter to get the coefficients. Write your equation given the found coefficients. The coefficients it will give you is M, that's the slope. It will give you B, that's the y-intercept. And it will give you R, that's the correlation coefficient. So pause the video, go ahead and rewrite these steps in your own words, and then we'll move on. Okay, let's look at number 8. Which equation would best model the data from month 1 to month 9? We have months and we have temperatures. Months is going to be time. Time is almost always X. And then temperature will be your Y values, your outputs. So we'll go ahead and go to our calculator and we'll press the green beaker. If there are tabs already open, let's clear those. Press Control W, no, and then start over. So we click the green beaker first, and then we click the table. Type in the X values into the X column and the Y values into the Y column. After you have your table of values input into the calculator, go ahead and click the little graph icon at the bottom. The reason why you have to press this first is because if you go to menu, 4 will not work right here. So let's click the graph. Menu, 4, Analyze, 6 curve fit, 1 linear. Now we have this table that shows up. Keep pressing down until you get to the bottom. Right there. From here we have our M, our slope, 2.8. We have our B, y-intercept, 88.3. And we have our R, correlation coefficient, 0.92. So using that information, we'll go ahead and fill in these blanks right here. So our M, our slope, we can write 2.8. For our B, by the way, the slope is temperature per month. Okay, B, our y-intercept, we could go ahead and put 88.3. And our R, let's put 0.92. 0.92 is positive, and it's further away from 0, so it is a strong positive. Okay, let's look at our answer choices and compare them to our results. So our M is 2.8. So y equals mx plus b. The m has to be 2.8. Well, this one doesn't have it. This one doesn't have it. This one has it. And that one doesn't have it. Let's double check. Make sure our b is the same. We don't have 88 there. No 88. That was pretty close. This one works. That's way far away. So our answer would be B. Let's look at number 9. Use the graph to answer the questions below. You'll draw a line of best fit. To draw our line of best fit, just take your pencil, connect as many points as you can without making it a curve, and there you go. That is your line of best fit. Now, is there causation? Is this a cause and effect? Basically, if you do one of these things, does it always result in the other? No, it does not, because the points are not all on the line. C. Last Saturday, 50 people attended a movie. Approximately how many movie screens were used last Saturday? So we have 50 people and they attended a movie. That's your Y value. How many movie screens were used? That's the X values. So if you go to your graph, have 50 people, that's right here, and we're going to find the X value right there. So where do these lines cross? Where do they intersect? Right here. That X value looks like it's about 3. So X equals 3 movie screens. D. On Friday, 8 movie screens were used to show movies. About how many people attended a movie? underline 8 movie screens and how many people attended. Movie screens is X, the people attended is the Y. Now, if you're not sure about this, it does say on your graph. So if you look at the graph, notice that it has on the y-axis people, and on the x-axis it has screens. So it has 8 movie screens. So let's find where x equals 8. You could draw a line, and where they cross, where they intersect, is at 120. So your answer would be y is 120 people. Alright, let's look at number 10. The cost of a flight is related to the distance traveled. Find the following. So we're going to need our calculator for this. So let's go to our calculator. Clear all this out. Control W, no. Click the green beaker. Click the table. Type in your X values, which are miles, and your Y values, that's the cost. Notice on this table, I did not put the commas for the thousands numbers. Don't do that. Do not put a comma right there. It messes up the answers. So let's go to the little graph icon. Menu 4, 6, 1. Scroll down with the arrow key. There's your M, your slope, B, your y-intercept, and R, your correlation coefficient. We're going to go ahead and record these on our paper. So the slope is about 0.094. Your B, your y-intercept, is about 29.24. So the line of best fit, y equals mx plus b, you have y equals 0.094x plus 29.24. Your correlation coefficient was 0.988. Okay, what does the correlation coefficient tell you? Well, we know it's positive because there's no negative sign, and it's further away from 0, so it's strong. Strong positive correlation. Use the line of best fit equation, which is up here, to determine what the cost of a flight that travels 3,245 miles would be. So, our miles is the x, and remember y is a function here. We can also call it f of x. So our input is going to be 3,245 miles. So if we write that into our expression, we have 0.094 times, or parentheses, 3,245, close parentheses, plus 29.24. And if you work that out, or you put it in the calculator, you get about $334.27. Number 11. For each correlation coefficient, determine if the correlation is a strong negative, weak negative, no correlation, weak positive, or strong positive. So if we recall our line from before, our diagram, if we have 0, that's no correlation. If the R value is close to 0 in this area, it's a weak correlation. And if it's far away from 0 and closer to either -1 or +1, it's strong. Pause the video, try to figure out what kind of correlations these are. Okay, the first one we have -0.13. It's negative, so put a negative. 13. Well, 13 is closer to 0 than it is to 1, so that is weak. The next one we have -0.72. That's also negative, but it's further away from 0, so it's strong. Okay, R equals 0.987. That's positive, and it's close to 1. It's further away from 0, so it's positive strong. R equals 0. That's no correlation. R equals 0.431. That's positive because there's no negative sign in front of it. And it is closer to 0, so it is weak. 1. R equals 1. Well, it's positive. It is very far away from 0, as far as it can be on these, so it's very strong. Okay, we have -0.879. That's negative, and it is strong. It is far away from 0. R equals -1. Well, that's negative, and it's very strong. It's as far away from 0 as you could get for these. And then the last one, -0.321, that's negative and weak. It's closer to 0. Number 12, function notation. Note, f of x equals y may be written as the coordinate x comma y. Rewrite the following function values as a coordinate. F of 4 equals 9. The thing on the inside is the x. The thing on the outside is the y. So your coordinate is 4, 9. Pause the video, try the next one. W of -3 equals 8. What is the coordinate point? Okay, the answer is -3, 8. That is your coordinate point, x, y. Find the missing value in the following functions. So we have g of -1.3. So we're looking at the g function, not h, not p, g. So when x is -1.3, y is 4.4. So that's your answer. Okay, now we're doing the opposite. When g of x equals negative 3.7, x equals 0.6. When y equals negative 3.7, x equals 0.6. Let's look at our graph function, our h of x. With h of negative 2. Basically, when x is negative 2, the y is 4. When h of x equals 8, x equals, so here's where y is 8, x looks like it is 3. And let's look at our equation. P of x equals 6 parentheses x squared plus 2 close parentheses plus 10. P of negative 2. So you want to evaluate this. So you have 6 parentheses negative 2 close parentheses squared plus 2 close parentheses plus 10. This is exactly what you would put in the calculator. Don't forget parentheses matter. Put extra parentheses if you need to. And if you plug that in, you get 46. Let's look at P of 4. Pause the video, see if you can set it up like this. Wherever you see an X, you replace it with parentheses 4. Okay, this is the expression you should have gotten. We're going to put this in the calculator, and then you get 118. So you get 118 right here. Let's look at number 13. Batman can hold 18 batarangs in his utility belt. On average, he uses 2 batarangs for each criminal, one to disarm him and the second to make him unconscious. Let Y represent the number of batarangs left in his utility belt after using them on a criminal. Let X represent the number of criminals. So let's highlight or underline some important words and numbers. We have 18 batarangs, and he uses 2 batarangs for each. For each. Remember, when you see the word each or per, that's the slope. So your rate of change. So is this discrete or contiguous? It should be discrete because we count the batarangs. What would be a reasonable domain? Since this is discrete, we're going to have a set. We're going to list the elements, the numbers inside. So we have 0, 2, so 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And that is representing the number of criminals. The range, the reasonable range, you would list the Y values. We have 0, 2, 4, 6, 8, 10, 12, 14, 16, and 18. And those numbers again are representing the number of batarangs. So we want to name this graph. Let's just call it Batman. Okay, our x-axis, let's call it number of criminals. And then our y, we'll put number of batarangs. Okay, so using all that, let's find our equation. So, originally they start with 18 batarangs. So that's our y-intercept. He uses 2. So when somebody uses something, they take it away. So that's a -2. This is our 18. This is B. This is our slope, M. So our equation would be f of x equals -2x plus 18. Okay, let's move on to another one. Wait, first let's go ahead and sketch a graph. There. So our first point on the end would be 0, 18. And then on the right side, let's have 9, 0. Number 14, finding slope, rate of change from different representations. Table, what is the rate of change, slope, for the table? So we have our x column and our y column. So first, we want to find our change in x, and we want to find our change in y. So for a change in x, from -2 to 0, we add 2 to that. From 12 to 3, we take away 9. Remember, our slope is going to be the change in y over the change in x. So if you put those in, our change in y is -9, and our change in x is +2. A negative divided by positive is a negative, so our slope is -9/2. Now there's another way you could find this answer. You could use the slope formula m equals y2 minus y1 all over x2 minus x1. And we could say that here's our 2 points, -2, 12, and 0, 3. -2, x1, y1, x2, y2. Plug these into the formula. You should get the same thing. Let's find out. y2 is 3, so we replace y2 with 3. We have 3 minus y1, which is 12, all over x2, which is 0, minus x1, -2. 3 minus 12, -9. 0 minus -2. The two negatives make a positive. You get +2. You get the same answer. Let's look at a slope of 2 points. So what's the slope of the line that passes through the points 26.7 and negative 37.15? Label them. x1, y1, x2, y2. Recall your formula from before. M equals y2 minus y1 all over x2 minus x1. Plug those into the formula. We have 15 minus 7 all over negative 37 minus 26. When you solve that, you get 8 over negative 63. That's our slope. Let's look at the slope of an equation. What is the slope of the line represented by y equals negative 3/2 x plus 5? It's in the form y equals mx plus b, and m is our slope. Our m is negative 3/2. So our slope, our answer, is negative 3/2. Remember, you can only do this method right here if y is by itself. Let's look at the graphs. Slopes of the graphs. What is the slope, rate of change, of each of the following graphs? Let's look at the first one. We want to go over lattice points. That's where the grid lines intersect. This is a lattice point. This is not a lattice point. That's not a lattice point. Here's one. And there's one right there. Let's go ahead and draw our triangle. After we draw our triangle, we want to count how many it goes up, or rise. Before you do that though, you want to see how much each square is skip counting. From that square right here is from 0 to 1. So these squares are skip counting by ones. So if you count all the squares, you get 9. Okay, let's look at the other ones. How much does it run? From this square right here, it goes from 0 to 4. So we're skip counting by 4s. So we have 4, 8, 12, 16, 20, 24, 28. So that is 28. Is this a positive slope or a negative slope? It's a negative slope, so that means it is decreasing. So your slope is going to have a negative sign in front of it. Your rise is 9, your run is 28. So our slope is negative 9 over 28. And it's going to be miles per minute. That is your rate of change. That's your slope. Let's look at this graph. So we're going to find some lattice points. This is a lattice point. It's where it crosses both grid lines. This is also a lattice point. It crosses both grid lines. This one is also a lattice point, but we only need to label 2. So we'll make our triangle. Each one of these squares are skip counting by ones. So you count those 1, 2, 3, 4. It's rising 4, and it runs 1, 2, 3, 4, 5. It runs 5. Is this a positive slope or a negative slope? It's positive. So we're increasing. So our slope is going to have a positive sign in front of it. Our rise is 4 and our run is 5. So our slope is 4/5. That is our slope. That's our rate of change. And let's look at the last graph. They already labeled our lattice points for us. So we go ahead and make the triangle. And again, this one is skip counting by ones. And this is also skip counting by ones. So if you count them all, you get 6 right here and 8. Is this a positive slope or a negative slope? It's a negative slope, so it's decreasing. So you're going to put a negative sign in front of the slope. We rose 6 and we ran 8. Now we can reduce this fraction. They're both even numbers, so you can divide by 2. So our slope is negative 3/4. Let's look at some word problems. 15. Stories. What is the rate of change, slope, in the word problem? Mrs. Martin rides her bicycle 15 miles per hour on the trail. The trail is 20 miles long. What is the rate of change? 15 miles per hour. When it says per or each, that's the slope, almost always. The trail is 20 miles long. That's our y-intercept, our b. But we're looking for the rate of change. That's m. So 15 miles per hour. That's your rate of change. Mrs. Mondragon is signing up for a movie streaming service. The initial fee is $15 and an additional cost of $8 every month. What is the rate of change? If you see the word initial, entry, original, starting, any of those kind of words, that's your B. That's your y-intercept. If you see the word every or per, that's your M. That's your slope. So your rate of change is $8 per month. Mrs. Garcia is receiving a bonus for each student that shows up for SAT prep on Saturday. The school is going to pay her $10 for each student. Mrs. Garcia also gets paid an additional $100 for working Saturday. What is the rate of change? Says for each, that's M. The other number has to be the B. That's the original amount. Even if they had no students, it would be $100 for working that Saturday. So your rate of change, $10 per student. Number 16. Which of the following best represents causation? A. After taking medicine, the patient fully heals. B. When paper is lit on fire, it burns to ashes. C. When someone sleeps more hours, they feel less tired. D. When someone uses their debit card for something, the amount of money in the bank decreases. E. The more someone studies, the higher their test grade is. On the three associations that were not causation, describe why they are not causations under each choice. So looking at A, that is not causation. So it is only an association. Take a few minutes. What is some of the exceptions? So some exceptions could be the patient may not heal, they may have an allergic reaction, something like that. Okay, B. That one will be a causation. It is a cause and effect. C. This is not a causation. So it's an association. Think about some exceptions for this. One exception could be some people that get more sleep, it makes them feel even more tired. D. That is a causation. It's a cause and effect. If you spend money on something, you have less money left. And then E, that is an association. They may not always get a high grade from studying. Now, if you go back and look at these, what kind of correlations are they? Remember, associations and causations can have correlations here. So if you look at A, it would usually be a positive correlation. Basically, as the amount of medicine increases, they are supposed to have a more likely chance of healing. On B, that would also be a positive correlation. Basically, more lit paper means more ashes. Now for C, that would be a neither positive, negative, or no correlation. It'd be like a non-linear correlation. Basically for this, not enough sleep, more tired. Just the right amount of sleep, less tired. And too much sleep, more tired again. Okay, on D, that would be a negative correlation. It's a negative correlation because the more spending, the less money. And E, that would be a positive correlation. The more studying, the higher the chance of getting a high test grade. Number 17, sequences. Geometric sequence. A of n equals A of 1 times r to the n minus 1 power, where A of n is the nth term of the sequence, and A of 1 is the first term of the sequence. R is the common ratio. That's what you multiply or divide each time to get the new number. N is the position of the term in this sequence. So if we look at this example right here, our pictures, we're going to go ahead and label the pictures. We have 1 square here, 4 squares here, and 16 squares there. So our first term in the sequence is 1. So we're putting 1 right there. R, that's our common ratio. What number times 1 is 4? 1 times 4 is 4. 4 times 4 is 16. So yes, it works. It is geometric. Our R is 4. A of n, plug it into this formula. 1 parentheses 4, close parentheses, to the n minus 1 power. Let's look at this sequence. 3, 6, 12, so on. A of 1, that's the first term. That's a 3. R, well, we have to multiply each time to get the next number. Multiply by 2. 3 times 2 is 6. 6 times 2 is 12. So our R is times 2. A of n, plug it into the formula. A1 is 3 times R, which is 2, to the n minus 1 power. That's your formula for this geometric sequence. Let's look at arithmetic sequences. A of n equals A of 1 plus D parentheses n minus 1, where A of n is the nth term in the sequence. A of 1 is the first term of the sequence. D is the common difference. It's what you add or subtract to get the next number. And n is the position of the term in the sequence. So let's look at number 1 here. We have 0, 5, 10. Our first term is 0. We are going to add 5 each time. So our D, our common difference, is plus 5. A of n, plug it into the formula. A of 1 is 0 plus D, which is 5, n minus 1. Now this isn't simplified. So let's go ahead and rewrite this over here and simplify it. 0, that just goes away. Distribute the 5, multiply each term by 5. So we have 5n minus 5. That would be our simplified equation, 5n minus 5. Let's look at the next sequence. 1, 3, 5. Our first term is 1. Our common difference is plus 2. Adding 2 each time. Plug it into the formula. Let's go ahead and write right here to simplify. 1 plus 2, parentheses, n minus 1. Distribute, multiply each term by 2. We have 1 plus 2n minus 2. Combine your like terms. You have negative 2 and 1. That gives you negative 1. So 2n minus 1. So your formula is a of n equals 2n minus 1. Let's look at the next one. Negative 2, negative 7, negative 12. Our first term in the sequence is negative 2. Our common difference is subtracting 5. Let's plug that into the formula. A of n equals negative 2 minus 5, parentheses, n minus 1. Distribute, multiply each term by negative 5. Combine like terms. 5 minus 2 is 3. So we have negative 5n plus 3. Number 4, 7, 10, 13. So our first term is 7. Our common difference, we're adding 3 each time. Plus 3, plus 3. And always try the first 2 or 3 to make sure that it's still plus whatever number you got. If it's not the same, it could possibly be a geometric sequence or something else entirely. So put plus 3, plug it into the formula. 7 plus 3, parentheses, n minus 1. Distribute the 3, multiply each term by 3. We have 7 plus 3n minus 3. Combine like terms. 7 minus 3 is 4. So our answer is 3n plus 4. A of n equals 3n plus 4. Let's look at number 5. Negative 7, negative 9, negative 11. Our first term is negative 7. Our common difference is subtracting 2 each time. A of n, plug it into the formula. Negative 7 minus 2, parentheses, n minus 1. Distribute, multiply each term by negative 2. So I have negative 7 minus 2n plus 2. Combine like terms. Negative 7 plus 2 is a negative 5. So your equation is a of n equals negative 2n minus 5. Pause the video, try number 6 on your own. We have 7, 14, 28. So we add 7 here. First term is 7. Common difference, well, we add 7 here, but we add 14 right here. So this is not arithmetic. This is geometric. So we'll change that to an R. So we multiply by 2 each time. So I plug it into the geometric formula. A of n equals A1, which is 7, times 2 to the n minus 1 power. There's no simplifying needed here, so that's it. And let's look at the last one. What comes next in the pattern? Try it out. Okay, notice we have 2 squares, 2 squares, 3 squares, 3 squares, 4 squares, 4 squares. What's going to be next? We have 5 squares, 5 squares. So we have our 5 squares by 5 squares. Okay, that's the end of this review. Good luck on your CA number 1.